Let's talk about a theoretical but exciting part about Java, the Java memory. This is actually a huge topic that we'll only cover to the extent that is necessary at a junior level. This is such a big topic, you can write a book on it. Not to brag or anything, but I did. It's actually not really a big book, but still. Long story short, the coverage in this course is somewhat simplified, but it will help you to grasp the basics. Let's talk about the different parts of the memory in the Java runtime environment. And these include the heap, the stack, and the meta space, also called the method area. The heap is the memory region where objects are allocated. It's divided into sub-areas depending on how long objects live on the heap. Then we have the stack. The stack is the area where method calls, local variables, and references to objects on the heap are stored. Each thread in your Java program has its own stack. The stack is organized into stack frames, with each frame containing information about the method call, such as its parameters and local variables. Then we have the method space. The method space is the region where class information such as class names, method names, and field names are stored. This area is shared amongst all threads in your Java program. Let's say we have the following code snippet. When executing this code, the stack memory keeps track of the method calls. Right now, our program didn't start yet, so the stack is empty. As soon as the code starts, a record gets added for the main method. The first line of the main creates a variable x and gives it a value. This is added to the stack record. The next line, int y is 7, does something very similar, and y is added to the stack record as well, including its value. Then something interesting happens. Our main method calls another method, and since this is another method, a new stack record is created for this. Variables in this method are added to this record, and from this method we cannot access variables in other stack records. This pretty much explains the scope of local variables. These are only accessible inside the method. So the next line creates a new int sum, and this is added to the add methods record on the stack as well. Next, the method returns the value and is done executing. The stack record is removed. After that, the main is done too. There are no more records on the stack and the application is done. This application had no objects, so there was no need to add in the heap. Let's modify the example to use an object. We are now creating a car, setting the color, then calling a method with this car and another color. In this method, we change the car to the new color. Let's walk through it line by line and see what happens to the stack and heap memory. Alright, so on line 1, we create a new instance of car. And this car is on the heap, so on the stack we're not storing the car object, instead we're pointing to where we can find this on the heap. We call this a reference. And right now I use @100 to symbolize this reference. On the next line, we set the color to blue. And you can see that the color on the car now has the value blue. Next, we call the method modify and we send in the reference of our car and the color pink. So you can see that both the add and the main now hold a pointer to the same reference on the heap. And in this method, we actually change the color of the car. So instead of blue, the car is now pink. After this, our method is done executing. And we're back in the main. And what we want to do here is print the value of the color of the car. And as you can see, our main is pointing to the same object on the heap. And even though in the main method we set the color to blue, we passed in the reference to the modify method, which updated the value to pink. So the key here is that there is only one car. Compare it like this. If I have a car and you borrow my car and you then paint my car pink, when you give it back to me, it's still going to be pink. I might actually be pleased, but still. There's only one car, that's the point here. And when we pass in the reference, we're pretty much pointing to the car on the heap, and both the main and the modify, we're pointing to the very same method. So it's actually slightly more complicated than this, because the string is an object itself. So there will be objects for both the strings on the heap as well, and the car object will point to another object itself. So on our car object, we hold a pointer to another object. And as you can see, the string value for blue is also still there, but we're now pointing to the one with the value pink. And then, I'm not going to explain this in any detail, I just want to give you a heads up. Strings are actually a special type of object. And the Java memory deals with the string pool to take care of them, but this is definitely beyond the scope of what you need to know right now. When we allocate memory, we have less memory available. Luckily, memory can also be deallocated. The stack is deallocated automatically. As soon as a method is done executing, the stack frame gets popped. For the heap, this is more complex. The garbage collector takes care of this. Let's explore how this works in the next video.